All right. So what is VPC? VPC stands for Virtual Public Cloud. You can imagine it as like a boundary through which the resources that you're using inside your AWS environment is secure and it's isolated from the outside world. So nothing from the outside world or any third party outside sources can access your resources in your AWS environment. So it acts as a boundary where your application and resources are isolated from the outside world. So whenever you're creating your VPC, you have to give some sort of a network as to which network is this going to belong to, and you're doing that using the CIDR block. But after that, after you have created your VPC, you then create your public subnets and your private subnets, and you define in which availability zones do you want your public subnets and private subnets to be in. So for example, if I'm just configuring this public subnet, this private subnet for my availability zone A, you would want to create a duplicate of this in another availability zone, just in the case if these subnets or these resources, or if the availability zone A goes down, then you need to have your backup in availability zone B to be accessed and then resume your application. So for that case, you are creating your public subnets and private subnets across multiple availability zones. So once you have created your VPC, once you've configured your subnets, you want to then give access for the internet to access your public subnets, because that's the reason why you're creating the public subnet in the first place. So the first thing that you're going to do is you're going to create an internet gateway for your VPC, and then you need to attach your internet gateway to your public subnet via a route table. So I'll just read this out, and also the fact that whenever you're working with VPCs, or you will first of all define in which region are you in. So first of all, you define what region you are in, you define what your VPC is going to be about, which is by defining its CIDR block. So for example, this VPC is for the network 10.0.0.0/16, and then this availability zones, you are going to create your subnets, place them in their availability zones, then you're going to create your internet gateway, attach that to your VPC, and then you need a route table to route the traffic from the internet gateway to proper subnets. A main route table is created on default with the VPC to help the route the traffic between these subnets in VPC, which means when you are creating your VPC, there is one route table which is already created inside this VPC, which can allow you to which can allow your public subnets and private subnets to communicate with each other very easily. Then you're also creating a custom route table with 0.0.0/0, which basically means the internet. Target equals to internet gateway to basically allow so you're creating this custom route table to allow the internet, which is 0.0.0/0, to communicate with this public subnet. Now, once you have allowed the internet to communicate with your resource in AWS, you actually need to have some security principles. You need to have some security control mechanisms to only allow data from a secure source. So for that, we will be talking about as to how you can maintain security in a VPC. You do this by two things. One is your NACL, which is network ACL, and the second thing is by doing it by security groups. So let's talk about network ACL first and then security groups. So in network ACL, you can imagine this as like a firewall at a subnet level. So there's your subnet, and there's a firewall, a boundary outside of this, which is encapsulating your subnet. And this is basically controlling the traffic that can either enter the subnet or leave the subnet. Whenever you are configuring your network ACL for a subnet, you also have to define the inbound and outbound rules. So for example, if you only want the HTTPS, there should be an S over here, S traffic to basically flow inside the subnet, then you're going to say that it's going to have port 50, the type is going to be HTTPS, and you're going to allow this connection to let the sources or resources enter into this subnet. So for example, if you are sending a request to the subnet or some EC2 instance in this subnet, then you would want to configure an inbound rule. You also need to configure the outbound rule as well, because if you are creating, for example, an HTTP web application, then it is going to receive some request from the outside world, and it must also send out response to the outside world as well. So for that, you also need to configure the same outbound rule for your inbound, which means that 50 HTTPS and allow that as well. This is because of the fact that the network ACLs are stateless by nature, which means that when you're configuring the inbound rule, you also need to configure the outbound rule as well. By default, everything is allowed, right? So when we said that we were attaching an internet gateway, we were allowing everything to occur. So you can think of it as this diagram, in which you have, this is the internet, and this is your public subnet. And by default, everything can enter to this public subnet. But what you do instead is by saying, okay, let me just allow HTTPS to flow through. So now with adding a network ACL, you just said, okay, now just allow HTTPS network to flow in. So you're basically constraining yourself. Okay, so let's move on. You have allow and deny options over here. We evaluate all the rules before deciding whether to allow the traffic or not. Okay, so over here, one thing that I do want to point out is you have different values over here, and the network ACL will always choose the smallest value first, and then it will go towards the other values. So next, let's talk about security groups. So you can now imagine that security groups are the firewalls that exist at the EC2 instance level, which means the resources. So inside your subnet, whichever service that you're using, for example, if you're using EC2, then the firewall exists at this level. The network ACL was outside the public subnet, but the security group is at the instance level. So security groups are not they're not optional. So every time whenever you're creating an EC2 instance, you need to configure and place that into a security group. The default configuration of a security group blocks all inbound traffic and allows all outbound traffic, which means nothing can enter inside by default, and you need to configure your security group. So if you want your EC2 instance to accept traffic from the internet, you need to open the inbound ports in the security group. So for example, you have your inbound rule as saying that I want to accept the traffic from 80 and 433 for HTTPS. So now the traffic from HTTP and HTTPS can now enter into this network. And you don't need to configure the outbound rule because your security groups are stateless, which means, they're stateful. They're stateful, which means that you don't need to configure outbound rules and you can let the traffic leave the instance. So once you've configured the inbound, the outbound is automatically configured because they're stateful. They are stateful resources because it will remember if the connection is originally initiated by the EC2 or from the outside world without needing to modify the inbound rules. Stateful returns traffic automatically allowed regardless of the rules. So we process rules in number order when deciding whether to allow traffic or not. Okay, so if you want convenience, you can just set up your network ACL to default configurations, which means you don't have to define your inbound outbound at all, and you can configure your security groups and your EC2 instance will work just fine, which basically means that When you just create your VPC, you can let your network ACL configurations to be as default. You don't need to create your inbound outbound rules, which means that your traffic can flow inside your subnet and everything is basically allowed. And you can then set your security groups by saying, okay, let the traffic in for the AD and HTTPS for your EC2 instance, and your EC2 instance will work fine. Okay, so some more information about VPC. So VPC allows the users to use AWS resources in a virtual network. So this was a virtual network that you were creating, in which it was like a boundary through which only your resources were kept isolated from the outside world. If you wanted to communicate or if you wanted to communicate with the outside world, then you were creating an internet gateway, attaching it to VPC, creating the route table for the traffic to route from the internet gateway towards your subnets which you have defined. um, so you are doing all of that. If you want to route traffic from the public towards your private subnets, for that you will be using NAT gateway. Okay, so it allows users to use AWS resources in a virtual network. You need a CIDR block and ACL. We will be talking about this in a little while. We talked about different securities, which were security group and network ACL. We talked about subnets, gateway, route tables. So it's very easy to use. And you can also expand VPCs by secondary IP ranges as well. There's one concept about elastic IP address. So elastic IP address is basically like a static IPv4 address, which is designed for dynamic cloud computing. One is allocated to your account, which can be used for all of your instances. So you can imagine one big IP which is given to you to your account, and then from that you're basically creating a lot of different subnets and utilizing that. VPC can privately connect to other AWS services without internet gateway, NAT, or fire proxy, but you can do that using VPC endpoint. So if you want your VPC to privately communicate or connect with other AWS services, then for that you will be using VPC endpoint. So for example, if you want your VPC to connect to an S3 bucket or through CloudWatch or some other AWS service, then you would be using a VPC endpoint for it. But your internet, okay, so let's talk about these things. Internet gateway is to allow internet to flow from the outside world, from the internet to your public subnets. This is for your private subnets. I'm not sure about what firewall proxy does at this point, so I won't be talking about that. If you have a data center which is your private data center and you want that to communicate with your VPC, then for that you will be using a VPN connection. If you want to actually check what different IPs or devices are basically entering or communicating with your VPC or are entering your virtual private network, then for that you will be using VPC flow logs to know about what information is going inside and outside of your network. So VPC networking, if you want to communicate with the outside world with your public subnet, the IP address type for both the subnets should be same, which means that they should both be either IPv4 or IPv6. If you're using a IPv4 with 16 masks, then you're going to get 2 to the power 16 IP addresses. If you're using a mask of 28, then you're going to get 16 IP addresses. And if you're using the mask of 24, then 5 IPs are basically restricted by default. So .0 is for your network address, which was for your VPC. You can't use that. .1 is for the router to address. So you can imagine that there might be like a router which is communicating with the AWS. So router, you can't use that. Point 2 is for Amazon DNS to resolve your name resolution through internet gateway. You can't use that either. And you can't also use point 3 because that is reserved by AWS for future use. And you also cannot use the last IP, which is going to be .255, which is used for broadcast. So anything which is left in between, which is from 4 to 244, you can use that. Now, there's another concept about communication between two VPCs. So if you want to have networking between two different VPCs and you want to route the traffic between them privately, you are going to be using VPC peering. Why do you want to do it privately? You want to do this privately because it will allow you to have low latency. Um, it will simplify your network architecture. It will reduce the data transfer cost while it is still in the AWS internal network. It will enhance the security by keeping the traffic within the AWS. So within the AWS network, you are not only having a very high secure network, because you're in a private network, you're not communicating with the outside world. It is going to have low latency because this is going to be a very fast connection. It's going to simplify your overall network architecture, and it's also going to reduce the data transfer cost because you're still inside the AWS architecture. So to do this, we need to follow a method which is called VPC peering, in which your instances in either yes, so instances in either VPC can also communicate with each other. So for example, there's an EC2 instance here, an EC2 instance in this VPC, then, and if this is of CIDR range 10.0.0, and this is for 172.31.0.0, then these EC2 instances can communicate with each other. There are some restrictions in which you can't use VPC. So for example, if you have overlapping CIDR block, you can't do this. For this, you would have to have some sort of like a wrapper, or there was or a whitelist for the same VPC to overcome this problem. But mostly, if there's an overlapping CIDR block, you can't do it. You can't do transitive pairing. So what is transitive pairing? Um, so transitive pairing is that if you have three VPCs, so VPC A, B, and C, and VPC A is communicating or has a VPC peering connection with VPC B, and B has a VPC peering connection with VPC C, then you cannot, transitive VPC pairing states that you should be able to communicate A with C. So transitive, this is the transitive property. If A can talk to B, B can talk to C, which basically means that indirectly A should be able to communicate with C as well. Transitive VPC peering is not allowed in AWS. It can be configured using a central transit VPC, which acts as a hub through which inter VPC communication flows to allow transitive pairing in AWS, which means that if you have like a central transit VPC that can act as a hub, and then through that every VPC will be connected, and every VPC will be able to communicate with each other. But by default, you can't do this in AWS. So you can't do you can't do transitive pairing. You also cannot do edge-to-edge routing through gateway or private connection. So what this basically means is that if you have like a router, um, so if you have um, so you can imagine it like, let me think of an example. So if you have like a VPC here, and you have something which is outside, so let's say that this is AWS and this is outside of AWS, and you want to communicate with this device, so this is like edge to edge through a router, you can't do this. So you can imagine it like using like a VPN, right? So when you're using like a laptop and you want to go to a web browser but you can't do it, you use like a VPN for that. You can't do this. You can't have this similar process over here as well. So you can't do this. Edge to edge routing through gateway or private connection is not allowed. Okay, next, there are three types of VPC peering. You have intra-region, which basically means that within a region, you can have VPCs, but with different AWS accounts, they can communicate with each other. So this is for AWS account A, this is the account for B, this is VPC A, this is VPC B, and this is both these both VPCs and accounts are in the same region. They can do VPC peering. That is intra region. Inter region means that now they are in different regions. They can also do this. Transitive peering is the third type, which is not supported in AWS, but can be done using a central transit VPC hub. What were the benefits? We talked about the benefits as low latency between VPCs in different regions. So you can do this even in like different regions. You can have very low latency. You will have very good security because it's in the same architecture. It's simplifying the architecture. It is reducing the data cost, data transfer cost, because it's leveraging the AWS internal network. Limitations. So these were some limitations. Can be done for CIDRs, overlapping block, can be done for transitive peering directly, can be done for edge to edge routing through gateway or private connection, and it has a limit of the number of VPCs which are connected. So that means is that when I was connecting B with A and C, you can imagine this to be like a really big network in which multiple VPCs can be connected. They can't have transitive peering, but they can be connected to multiple VPCs. But there is a certain limit to it. Okay, so VPC peering setup. So now I'll be talking about how to set it up if you want to do this. So for example, you have a marketing VPC and a finance VPC, and you want to set up a peering connection for this. Let's imagine that this is 10.10.00 network. This is 172.31.00/16. The route table initially is just this, which is its default route table, which allows it to communicate with the services or the subnets inside this VPC by default. So you're going to create a peering connection. You're going to go and create a peering connection, and you're going to call it like marketing finance. The requester, for example, let's say that this is the requester, this is the acceptor, then you are going to accept the conditions that marketing can request information and finance can accept that. So you can do that by clicking the actions option over there. Once that's done, you are going to edit the route table of this marketing VPC and add the IP or CIDR for this over here, and you're also going to do the same for the route table for the finance as well. Once you have configured the route tables for both of them, you need to then add security group for the finance by adding the network ID of marketing as inbound, because again this is requesting it. So this is entering the subnet of this, and it's going to access the EC2 or whichever service that it needs to access. So remember when we were talking about the instances being able to communicate with each other, and whenever we're talking about instances, not subnets over here, but instances, we need to use security groups. So in order for the marketing VPC to enter this EC2, because in this case, it is considering it as an outside source, right? Because maybe that these two VPCs could be in different regions. So to allow the communication to occur or the networking to occur from the marketing to the instances in this finance server, you need to have a security group inbound rule for it, and you don't need to configure the outbound route. Why? Because you don't have to, because security groups are stateful resources. Okay, next, security measures. So you can encrypt your data when it's transiting using SSL or TLS or VPN. VPN if you are doing it through private data centers. You can implement security group or network ACLs. We talked about that. You can enable VPC flow logs to monitor your network traffic. You can also audit or review your VPC peering connection for compliance with security policies using either AWS configuration or AWS CloudTrail. So AWS Cloud configuration helps you to reduce the risk for your operational troubleshooting, compliance and audits, changing and management, and security monitoring. So it helps you to reduce the risk for operation troubleshooting, changing management, compliance and issues, compliance and audits, and your security monitoring. Lastly, you can also monitor and manage all of your resources of your VPC connection by using CloudWatch. So it basically creates like graphs for you, and you can also like create alerts through it as well. AWS configuration is used to track configurations or changes of your VPC peering connections and ensure compliance with security policies. You can implement automated backups for disaster recovery, or you can conduct performance testing with it as well. So that was all related to VPC.